Hello, and today welcome to the College Algebra edition of Complex Numbers. We're going to be discussing Chapter 1.4 in the Coburn College Algebra book. So to start out with, we need to define what is I, and the reason that we need I is because there's some things that we can't solve for. So for instance, if you're looking at x squared equals 9, and we want to then take the square root of both sides, actually, let's make that x squared equals negative 9. And you're going to take the square root of both sides. There's not a square root of negative 9 because there's no number times itself that will give you a negative number. And so we need to define I as the square root of negative 1 so that we can take the square root of negative 9. And if we use our product property for radicals, what I can do is I can split this apart in the square root of negative 1 and the square root of 9. And if the square root of negative 1 is I, then I get 3i. And in the case of doing a square root on a squared, we are going to add the plus or minus there. So in addition to knowing what I is, then we also really need to know what I squared is. And I squared then is going to be negative 1. Because if I square both sides here, the square root and the square cancel, leaving me with a negative 1. And it's very important to know these two, I and I squared, and then how we're going to be able to use them. So the next progression would be standard form for a complex number. And that is going to be a plus bi, where a represents the real part and bi represents the imaginary part. And so this is how we get then our complex number, is that it has a real part and an imaginary part. Even though one part, it doesn't matter which part, could be equal to 0. So from the textbook, the exercises on page 111, we're going to look at exercise number 23b. And it talks about adding and subtracting complex numbers. And so we get 3 plus the square root of negative 25. And we are going to add to it negative 1 minus the square root of negative 81. And what we first want to do is just realize that the parentheses are there to show us we're adding this complex number to this complex number. And in the case of addition, we don't really need parentheses, and so we're going to go ahead and drop the parentheses, and what we then need to do is rewrite these so that they're in terms of I and not negative radicals. So this would be 3 plus 5i, because the square root of 25 is 5, that negative underneath makes the I, minus 1 minus 9i. So what we want to do from here is just combine like terms, and you want to leave it in standard form, so you want your real part first, and if we combine our two real parts, we'll get positive 2, and then if we combine our two imaginary parts, it will be minus 4i. So there's an example with addition. If we go ahead and look at 25c, it's 6 minus 5i minus the complex number 4 plus 3i. So it's already in terms of I, but this time it's a subtraction problem, and so what you always want to do is distribute that minus sign. So it'd be minus 4i minus 3i, and don't ask me why I put an I there. No I there. Minus 4 minus 3i. And then finish still with combining like terms, and you're going to get 2 minus 8i. So there's adding and subtracting. So the next thing we want to talk about is multiplying complex numbers. Okay? And there's an important rule to follow when you're multiplying, and that is that you always want to change any square roots of negative k to I square root of k first, before you multiply. If you don't, you're going to end up with the wrong signs at the end. Okay? And then the second rule is going to be that you have to change any I squareds into negative 1s. And so if you can remember those two rules, really the only thing that we're doing is just distributing. And so let's look at example 32. And it says negative 7i times 5 minus 3i. And so we're just going to distribute that negative 7i into the parentheses, and we're going to get negative 35i plus 21i squared. Because remember that I times I, just like x times x, is going to be x squared or I squared. So then if we remember, though, that I squared turns into a negative 1, and it's 21 times negative 1, you actually end up with a negative 21 minus 35i, and then that would be in standard form. So if we look ahead to 33b, so that was multiplying by a monomial. What if we multiply two binomials? So 33b says 2 minus 3i times negative 5 plus I. Well, you're going to do just what you do whenever you multiply two binomials, and you're going to FOIL. So for first, we're going to get negative 10. Outside is 2i. Inside is 15i. And last is negative 3i squared. Again, that I squared turns into a negative 1, so that actually turns into a plus 3 at the end. We want to put our real part first, which is going to be negative 7 plus 17i. Okay, the next thing we want to look at with multiplying is multiplying by a conjugate, because you're going to have to do that when you rationalize denominators with i's in them. So if we go ahead and look at example 42 just says negative 5i, and the directions say to multiply by its conjugate. State the conjugate and then multiply by the conjugate. So what's the conjugate of 5i? Negative 5i. It's 5i. Alright, so a number times its conjugate. So here all we're going to do is multiply. You're going to get negative 25i squared, which becomes positive 25. Well, let's go ahead and look at 39b. 39b says 3 minus I squared to 2. Well, if I want to multiply that by its conjugate, what's its conjugate? It's 3 plus I squared to 2. Okay, so now I'm back to this binomial times binomial, and I want to FOIL. So for first, we get 9. Outside, you're going to write this a 3i squared to 2. Inside is a negative 3i squared to 2, or if the fact you remember anytime you take a number times its conjugate, that o and I of FOIL cancel. That would be helpful there. And for last, it's going to be negative I squared times 2, because the square root of 2 times the square root of 2 is just 2. Okay, so the middle two terms cancel. The I squared turns into a negative 1, and you end up with 9 plus 2, which is 11. Okay, and the reason we would want to multiply by the conjugate is because notice then we've totally eliminated I, which is what we're going to want to do when there's an I in the denominator. We're going to take a second and look at simplifying powers of I. It's kind of a neat thing. Not as daunting as it may look. But if we look at example 54, and 54a starts out with I to the 30th power. And so you're like, okay, what is I to the 36th power? So you want to base it off of I squared, and the fact that you know I squared is negative 1. So you want to rewrite this as I squared to some power. So if we remember, our exponent rule is a power to a power. We multiply, and so that needs to be 18. And then with a little substitution, then what you have is negative 1 to the 18th power. And if I take a negative 1 18 times, I'm going to get positive 1. So as long as you base it off of I squared, you should be fine. So 54c says I to the 19th power. And so sometimes you can't base it, it's not an even number, let's put it that way. So I can make this I squared, but I'm only going to make this I squared to the 9th. So there's 18 of my i's, and so I'm going to have to take this by times another I to get all 19 i's there. So if this is negative 1 to the 9th, that's going to end up as negative 1, and we get negative 1 times I for negative I, and that would be our answer there. Alright, up next we're going to look at division of complex numbers, and really what we're looking at is then rationalizing, because you can't have an I in the denominator because an I is a square root, and you can't have radicals in the denominator. So if we start out by looking at 55b, and 55b says 2 over 1 minus the square root of negative 4, and earlier I said you always want to change those negatives under a radical into i's first, so we're actually going to make this 1 minus 2i. Okay? So the fact that there's an I in the denominator tells me there's a radical in the denominator, and I can't have that, so I'm going to multiply by its conjugate, which is 1 plus 2i, top and bottom, right? Anything over itself is 1, so I multiply by 1. And so we're going to do a bunch of distributing here. So on top, the 2 gets distributed, because remember, a fraction bar is a grouping symbol, so I have all these groups. So we're going to get 2 plus 4i, and on the bottom, I'm going to FOIL, and I'm going to get 1. And then if we look ahead here, we get a positive 2i and a negative 2i, and they're going to cancel, because I'm multiplying by a conjugate. And it looks like then we have a negative 4i squared. That I squared, though, turns into a negative 1, and so then we get that whole thing there becomes a plus 4, and you get 2 plus 4i over 5, and thus we no longer have a radical on the bottom. I am a-okay with that answer. It does ask you to write it in standard form for a complex number, so splitting apart that radical, or sorry, the real part and the imaginary part. But either way, I'm okay with that, or if you would prefer to write it like that, that is fine as well. Okay, that's the bulk of 1-4. Let me know if you have any questions, and I will try to get those answered, and we will do 1-5 next. Have a great day.